Tonight, close your eyes and say one word. Any word. You did not invent that. Nobody alive did. That sound, that specific ability to shape air into meaning, is the oldest technology in human history. Older than fire, older than the wheel, older than farming. And for most of the last century, scientists believed we would never know where it came from. The human voice box sits lower in the throat than any other primate on Earth. That single anatomical fact is the reason you can speak and a chimpanzee cannot. The larynx dropped sometime between 200,000 and 300,000 years ago, and when it did, it opened something no species had ever accessed before: infinite combinations of sound. But here is the problem. Soft tissue does not fossilize. The larynx, the tongue, the lips, gone forever. Which means for decades, the origin of human language was considered scientifically untouchable. Then, researchers stopped looking at throats and started looking at genes. In 2001, a team at Oxford University, led by Dr. Simon Fisher, identified a gene called FOXP2. They found it by studying a British family, 3 generations of them, who all shared the same severe language disorder. They could not coordinate the mouth movements required for speech. They could not process grammar. They struggled with language at a fundamental neurological level. Every affected family member carried a mutation in the same gene. FOXP2 was not just linked to language, it was linked to the physical machinery of speech itself. Then came the truly strange part. When researchers compared human FOXP2 to the same gene in chimpanzees, they found only 2 amino acid differences. 2 in the entire sequence. And those 2 differences appear to have been locked in by natural selection at least 400,000 years ago, meaning something about those mutations was so useful, evolution made sure they stayed. What were those mutations doing? They were fine-tuning motor control. Specifically, the precise, rapid, coordinated muscle movements required to produce speech sounds at the speed of normal conversation. You speak at roughly 150 words per minute. Each word requires dozens of micro-adjustments in your lips, tongue, jaw, and throat. FOXP2 is part of what makes that possible. And here is what makes this remarkable. Neanderthals had the same version of FOXP2 as modern humans. So, could Neanderthals speak? The evidence says yes, at least partially. In 1989, a Neanderthal hyoid bone was discovered at Kebara Cave in Israel. The hyoid is a small horseshoe-shaped bone in the throat that anchors the tongue muscles. It is one of the only bones that can tell us anything about the vocal anatomy of an extinct species. The Kebara hyoid was virtually identical to a modern human hyoid. Dr. D. Dina Bhatt at the University of New England later ran biomechanical simulations showing the Neanderthal hyoid would have functioned the same way ours does. Same muscle attachments, same movement range. Neanderthals could almost certainly produce complex vocalization. Whether that vocalization was language, structured, symbolic, grammatical language, is the question that still splits researchers today. But what did the very first language sound like? This is where the science gets strange and beautiful. In 2003, Dr. Alec Knight and Dr. Joanna Mountain at Stanford University published a genetic study tracking mitochondrial DNA lineages back to their origin point. The oldest surviving human population on Earth, the people whose genetic line reaches furthest back without interruption, are the Khoisan people of southern Africa. The Khoisan languages are built on click consonants, sounds made not with the voice box, but with the tongue, teeth, and palate. Researchers now believe click sounds may represent one of the oldest phonetic features in human language, preserved in these populations for potentially 100,000 years or more. When linguist Dr. Quentin Atkinson published his landmark 2011 study in the journal Science, he analyzed phonemic diversity across 504 languages worldwide. His finding was extraordinary. Languages in sub-Saharan Africa have the highest phonemic diversity on Earth. As you move further from Africa, across Asia, into Europe, across the Pacific, into the Americas, phonemic diversity drops consistently. This is exactly the pattern you see with genetic diversity. It matches the out-of-Africa migration perfectly. Which means language almost certainly originated in Africa. And the further a population traveled from that origin point, the more phonemic complexity was lost. The same way genetic diversity thins the further a founding population gets from its source.
So, what did proto-human language actually sound like? Linguists call the hypothetical ancestor of all human language proto-world. It is controversial. Many researchers reject the idea that all languages trace back to a single root. But the phonemic diversity data is difficult to dismiss. Based on what we know, the earliest human language was probably rich in click sounds. It likely had far fewer vowels than modern English. It was probably tonal, meaning pitch changed the meaning of words, the way it does in Mandarin or Yoruba today. And it was almost certainly built around the immediate physical world. Danger, food, direction, group.
Not abstract. Not philosophical. Not yet. Just survival, wrapped in sound. Here is the question that should be keeping you up at night. If language started in one place, at one time, with one group of people, how did it spread across the entire planet? The answer is, we carried it with us. Every migration, every crossing, every mountain range and ocean and ice field that our ancestors pushed through over 60,000 years, they brought language with them. And as populations separated, as groups lost contact with each other across thousands of miles, language drifted, sounds shifted, grammar restructured, words changed beyond recognition. Today, there are roughly 7,000 languages spoken on Earth. They sound nothing alike, and yet the phonemic diversity data suggests they are all branches of the same tree. Every language you have ever heard, English, Mandarin, Arabic, Swahili, Hindi, is a variation on something spoken by a small group of people in Africa, possibly 100,000 years ago, around a fire in the dark. The word you said at the beginning of this video, you did not invent it, but somewhere in a chain of mouths stretching back 100,000 years, someone did. And the reason you can say it, the reason any human can say anything at all, is because at some point in deep prehistory, a small mutation in a single gene fine-tuned the muscles in a human throat just enough to make meaning out of air. Language did not make us human, but it may be the reason any of us are still here.